Hello, thank you very much. This is Kevin Pearies with Exfo, and we'd like to thank you for joining us today on this webcast of fiber inspection and cleaning. So as a technician, probably one of the primary functions I had, honestly, was just chasing dribbling errors in a transport system. And particularly with today's newer amplified systems, we're seeing this being more and more prevalent in the industry. So probably 80% of all network failures are attributed to dirty connectors, and it's such an easy thing to resolve. It's simply just cleaning contamination off the end face of the connector. But there has been a lot of improvements over the years to really capitalize on the efficiency of cleaning connectors. So today on this webcast, I'll be talking a little bit about inspecting connectors and cleaning them as well. I'm using the FIP 430B automated inspection probe, which really cuts down on the time it takes to inspect these connectors. And so as you'll see, within the video, it does auto analysis, auto inspection, auto capture, and auto centering and auto focus. So it truly is a really automated test application. And so again, this is such a key problem that we're seeing in the industry. In fact, this week alone, I've been in the field, and yesterday I did entire 6 hours of training on connector reflection, isolation, and cleaning. So this is a big problem across the industry, and so we hope that you enjoy this webcast. At the end of this webcast, we'll be taking some questions, and we'll also have some attachments that were included, and we'll be able to get your feedback and then answer some of your questions. So we hope you enjoy this presentation. Thank you very much.
Hello, my name is Kevin Pearies. I'm a Senior Applications Engineer at Exfo, and on today's 15-minute or less series, we'll be covering fiber cleaning and inspection. So here in front of me, I have several tools. I have the FTB1 platform from Exfo. Plugged into that is the FIP 430B automated fiber inspection probe. So we have several different versions of the 400 series fiber inspection probe. This particular one is the it has some great capabilities. It does auto capture, auto analysis, auto reporting, and auto focusing and auto centering. And so it's really a great tool. And so in fact, you'll see just how powerful it is here in a minute when I plug it in. I also have here a fiber patch panel, and so I'll be using this to inspect some of the bulkhead side of the fiber inspection, and then showing you how we clean those as well. I also have a single mode fiber jumper here. One side is a UPC connector, and the other side is an APC. So they do have different types of ferrule tips on them. I'll probably be working more with the blue UPC connector here. One thing about jumpers, so if you notice, this one still has the protective cap on it. There's a misconception that as soon as you take a jumper out of the package, that it comes clean from the factory, and this is definitely not the case, as I'm sure many of you have realized. And so the protective cap on here really is more for protection and not necessarily for cleanliness. And so, obviously with the cap on there, it'll reduce contamination, but if there's any contamination on the actual cap itself or inside of this, you'll of course cross-contaminate onto the fiber core itself. And so it's always important to inspect your jumpers, even if they come straight from the factory. I also have some fiber cleaning tools or solutions here as well. And so for my dry tissue, I'm using the Cube or QB, however they pronounce that, from Chemtronics. So this is a dry tissue method. I'm also using the Electro Wash from Chemtronics as well. I have the IBC Click It, and then of course my fiber jumper, and also some cleaning sticks as well. And so we'll go over the different methods of cleaning. Really for most folks, probably the dry tissue, or using like a Cleatop or some type of real type cleaner is really what most people are using today for cleaning. Of course, the downside to just using the dry wipe, so essentially just, with the cap here and, just drawing the fiber across the dry tissue. Some of the downsides for that is if there's any sort of contamination on there that might scratch the core, as you use the dry tissue, you might pull that across the core and cause some scratching. So there is a chance of that. And then, you can also have a bit of a static buildup charge going across the dry tissue. So as soon as you clean it, you might pick up some particles. But it really is a quick and easy way to clean a jumper. It's very convenient. And so that's the dry tissue method, just using this. Now, of course, there's also the wet method, and this is the hybrid method, they might call it, wet to dry. This is the method that I like to use, as far as the most impactful way to clean. And so for this particular solution, what I do is I'll wet a portion of the actual tissue itself. I will take the fiber connector or jumper, start in the wet portion and pull into the dry. And I like to scoot across and go about 3 times. So that's essentially how I normally clean. It's kind of a wet to dry method, using this hybrid method here. And then another way to clean, of course, is with the click it. So I'm a big fan of these for cleaning bulkheads. When I was a technician years ago, I spent a lot of time cleaning patch panels, entirely too much time actually. And so you could use, your cleaning sticks and those little swizzle sticks to clean the fiber port on the bulkhead side. So, basically on the female side of the connection. But really, you didn't have a lot of control over it. So these one click-its, what they brought to market, which I think are pretty cool, is it's basically a little ratchet device, almost like a punch-down tool, that has a piece of floss in there, like a cleaning floss. And as you place it into the actual bulkhead port, you can ratchet down a few times, and then it'll run that dry floss across the bulkhead. And if you put the cap on itself, you can plug in your fiber and clean that as well. This particular one happens to be an LC, so it's not going to work with this 2.5 millimeter. But it's basically the same design for those ones as well. And so these are the the click-its themselves. So let's go ahead and inspect the connector real quick. So again, this is the FIP 430B. I have it on the FTB1 display. So I'm actually running VNC via the NIC card here directly to my laptop. So I could do a screen capture of what I'm doing here so you can see it. So you'll see it here, and then of course you'll see it over there as well. I'm going to turn this a little bit so I can see. So I have, again, the single mode jumper here with a Sam Charlie UPC connector. And then, of course, I have the appropriate tip. Actually, I don't have the appropriate tip. So on here right now, I have this Sam Charlie, Frank Charlie bulkhead fiber inspection probe tip. I could change this out to the 2.5 universal version of the bulkhead tip. But here's a cool little trick that somebody showed me. So essentially, you take a bulkhead adapter. So you can grab this out of a patch panel or somewhere, and you just put it onto the end here. And then now I can inspect the actual jumper itself. So we auto center and auto focus. Now I have the auto capture and the auto analysis turned off right now, but I will turn it on here in a second. But essentially this is what we're seeing right now is the actual fiber core or the fiber connector itself. And so there, that dark circle portion there, that's actually the cladding. You don't see the actual core itself, only because it's pretty dark. If I were able to get just enough light, and it's kind of hard with a UPC connector, but if you're able to get this just right, you'd be able to see the core in the middle. And the core is very small, so it's only about 9 microns. So it's right there dead center in the middle of this inspection here. I talked about the field of view button over here on top earlier, so I can change the field of view. And so you'll see 3 different levels of magnification there. And then, of course, if I want to inspect the bulkhead now, I'll go ahead and inspect the bulkhead. And so that's really a cool little trick using this bulkhead inspection, because normally, let's say we'll normal this up. Now, of course, I did a no-no here. I didn't clean the connector, and I plugged it in so I can get cross-contamination. But for this demonstration purposes, that's all right. So let's say that I want to inspect and clean this connector. So I'll go ahead and unplug it from the patch panel. And then grab my little bulkhead tip here, plug that in, and then go ahead and inspect the tip. And of course, we'll be able to see this again, and I can have it refocus and recenter here. So I'll go ahead and do that. So let me go. There it is. So now, of course, we're seeing that tip. Now, if I want to look at the actual bulkhead itself, I can go ahead and plug it in, and then we can do the same thing here. So you can see there's quite a bit of contamination here as well. Look at that thing. It's pretty nasty. And so that's really how you inspect, a connector real quick. And you can see the cool options or the cool features in that auto center and auto focus. If I were to turn on auto capture and auto analysis on this particular unit, you get to see the whole test suite. So I'll go ahead and plug it in. There's little motors in here you can feel moving around while you're holding the probe. And then it'll auto center, auto focus. There it is. And then it'll auto capture it. And then do the auto analysis. And look at that. It's pretty cool, isn't it? And then, of course, we talked about the LED earlier. See the red LED? That is a fail. And so if we wanted to clean this connector, we'll go ahead and unplug it, remove this, I can start with the dry method first, if I'd like. So I go ahead and pull it out, hold it down, and just quickly clean the end of the connector here. Put my bulkhead tip back on. And then, of course, plug this back in. And we'll see what it looks like now. So there's the auto center again. I love the auto feature of this. It really is quite useful and a significant cost savings. And look at that. Now we have a pass, and we see green here, and that's what we want. And it's as simple as that. If I wanted to do the wet cleaning method, obviously this connector is already clean, but I'll go ahead and show that, how I do the wet cleaning method. So I'll go ahead and pull out some more of the dry tissue here. I like to hold it on the bottom of the box here. Just have put a little tension on it, and just a little bit of the cleaning solution in the corner there. And then I'll start in the wet, and then pull into the dry. 1, 2, 3. Simple as that. I would inspect it. If it's clean, plug it in. If I were to inspect the connector the first time and it was clean, then I would just connect it. And so, we prescribe to the inspect, clean, inspect, connect method. So if you inspect it and it's clean, then you connect it. If it's dirty, then obviously you clean it. And of course, you got to check both sides, because if there's any sort of cross-contamination of the actual connector itself, or if there's any contamination on this side of the bulkhead and you didn't clean it, you'll see the cross-contamination. So let me go ahead and show you what cross-contamination looks like. So I'm going to go ahead and plug this jumper in, and it should be clean. So I'm going to go ahead and run the test, let it auto-center and auto-focus here. So we obviously have some scratches here, so I'll see if I can clean that up. So I'm going to go ahead and unplug that, and I'll expand this, and I'll just use the dry method, just as we talked about before. Just clean it real quick. Plug in my little bulkhead here, and let's inspect this and see what it looks like. I might still have some of the scratches. Some of these jumpers, look at this, actually made it worse. So it's really not that uncommon to do that. But for this demonstration purpose, what I'm going to do is, I'm not going to sit here and clean it all day long. What I want to show you is cross-contamination. So on this side of the connector, it should still be clean or fairly clean. So I'll go ahead and plug that in and confirm that. And we're looking at it, and it's coming in, and we picked up some contamination, and all I did was set it down, right? So that's pretty interesting. So I'm going to go ahead and pull this out. So it's fairly clean, and this side was fairly clean. It had some scratches. So I'm going to go ahead and add some sort of contamination on there. I'm going to plug it in, then I'm going to unplug this, and then we're going to inspect this side to see what sort of cross-contamination we might have caused. So I'll plug it in, and look at that. You see that kind of crater effect, that halo effect around the cladding? That's what cross-contamination looks like. Because essentially what's happening with the connector is we have debris that's on the end, or contamination on the end of the tip. You plug it together, it mushrooms that together, right? And so it kind of does that cratering effect. This is a very clear example of what cross-contamination looks like. So if you unplug a jumper and you look at it, you see that halo effect? Most assuredly, the other side is also contaminated. So you need to really take care and clean the other side. So using something like a one-click, or gaining access to the back of the patch panel to disconnect the connector to access it with a dry tissue are really the two methods that you'll probably use to clear that contamination. So I'm going to go ahead and inspect this connector again. I want to talk a little bit about the different zones. So if you look at this connection, I'm going to have it run a quick test and an auto analysis, and then we'll step through what the results look like. So this one should be fairly clean. You should get a pass. There's a good green LED there. I'm going to go ahead, and again, I'm VNC'd, so I'm just reaching over to my mouse here. I'm actually controlling this platform here, so I'm looking off to the screen a little bit, but that's what I'm doing here. And so if I were to go to the results, we could see the 3 or the 4 different zones, rather, that we're concerned about. Zone A is the core, which is really one of the most critical zones there is. Any sort of contamination within this zone would create a fail and certainly a significant amount of loss. Then we have the B zone, which is the cladding itself, so that dark area. The adhesive zone, or C zone, and then the contact zone outside of that. And so you can see how we can measure the particle sizes and then compare them to an IEC standard. So in this particular one, I have this test configuration set for IEC, SIGA mode, UPC fiber. So if I go back to the image here, right here in the middle, it's kind of hard to see this green area. That's the core. This is the cladding. This is the adhesive zone. So sometimes you'll see some epoxy here. Then, of course, we have the contact zone here. And so this is these are the 4 zones that we're concerned about. So when we do fiber inspection based on the IEC spec, this is what we're looking at here. So I'm going to go ahead and generate a report based on this test that we just did. So I'll just go ahead and go into File. I can hit Report. and we can generate a report. So I'm on my laptop on this particular one, but certainly, well, showing it on my laptop, but this is actually on the platform itself. So I'll go ahead and generate a report, and as you notice, it was a PDF. And so if I were to navigate back into the file manager, so I'll do that on this here. So I'll do an Alt-Tab. I'll go back to the file manager here. And so at this point, you're in a Windows-based environment. We can see if we can find where that report is at. I should have looked to see where we saved it, but it should be under Connector Max 2. It was Fiber 7, so here it is here. So Fiber 7. And this is what the report looks like. It's really quite a nice looking report. And so you'll see all the pass fails. You'll see what the image looks like. You get all the important key performance indicators that we are concerned about when we're dealing with fiber. So during the BICSI conference last year, we did a challenge. We called it I think the Fiber Inspection Speed Challenge or something like that, where we used the patch panel and the newly introduced FIP 430B automated probe to, some of the folks that were attending the show, just having them stop by the trade booth and just, showing them how quickly they can inspect all the connectors across here. So just want to give you an idea of the power of the fully automated probe, because quite honestly, most of the technicians, and when I was a technician, spent a fair amount of time chasing dribbling errors in a system, in a transport system, and to a large degree, particularly in an amplified system, most dribbling errors that I worked on, well over 80% of it was probably a dirty connector, or was a dirty connector, so reflection. So I'm going to go ahead and just plug in here real quick, and we'll just zoom across here. You can see what it's doing. And I should probably turn off the auto capture and auto analysis. I could leave that on, but essentially you're seeing what we're doing here. So I got to fail. So I go ahead and hit the button, go to the next one. So that's all we're doing, we're just going across here. And there's that halo effect that we talked about earlier, so we had some cross-contamination on that one. I can go to the next one. So you get the idea of what we're doing here, right? It's pretty cool, isn't it? It's pretty incredible how quickly and how efficiently we can inspect the connectors. As long as I hold my hand still there. I've had a bit too much coffee here today. So we see what we're going on here. See that? There we go. I just got to hold still a little bit. The auto center was fighting my my caffeine shakes there, but you get the idea of what I was trying to show you there. Really, the efficiency of fiber inspection has been really increased tenfold with the FIP 430B, and I actually got this in the mail just today. The purpose of this video was not to show this, but just to give you an example of the innovation that Exfo's created. We now have a probe called the FIP 435B. So essentially it is everything that is in the 430B, but it is wireless. And so I have a smartphone here, my Note 4. Unfortunately, I don't have the software installed yet because I literally just got this afternoon. But I could use this as a Wi-Fi hotspot and look at my fiber inspection with this smartphone. So really just showing you some of the innovations that Exfo's created over the years, over our 30 years of development. And this is just one of the latest products. And I'm really, really anxious to get home, to get the application installed and to start playing around with this one here. So again, it's all just to make fiber inspection a lot more easy to do and a lot more fluid. Thank you very much for taking time out for this 15-minute or less session on fiber inspection and cleaning. I hope you found the information useful. I will provide additional links at the end of this closing to our Exfo support site with additional documentation and spec sheets on the products that I showed today, as well as some interesting videos and additional content like application notes relating to fiber inspection and cleanliness. Thank you very much.
Well, thank you very much. Hopefully you enjoyed this this webcast. I actually originally created this for a specific customer. They wanted 15-minute modules for training, so it wasn't actually intended originally for a wider audience. But our marketing folks found it interesting, and we hope you did as well. And so I'm going to go ahead and answer some of the questions. So somebody had asked whether, how much pressure you apply to the dry tissue. And so this is it's almost a subjective answer. It really depends on, the specifications from the manufacturer of the dry tissue. So for the Cantronics product, I believe they say to lightly draw it across the actual cloth itself. And so I wouldn't be too overly aggressive when you're cleaning fibers. I mean, there's a tendency to, if it doesn't come off, that you just rub harder and harder. So normally if I take the 2 or 3 passes, the 2 or 3 light passes, and you want to make sure you don't go over your original path. So as I mentioned in the video, you draw down and you scoot over. If I don't normally get it after that, then I will go to the wet-dry method to see if maybe that will work loose whatever the problem I had. So honestly, the answer is just to lightly draw it across, which of course is kind of like answering just snug. So it's a very subjective thing. So you want to make sure not to apply too much pressure. Now, as far as how often do you have to clean the probe, if you're seeing any sort of debris within the probe itself, and normally you can tell by just twisting the actual fiber jumper. So I'll twist the jumper. If the debris moves with it, then normally that's on the connector. If it doesn't move, then it's on the actual probe tip itself. So honestly, you clean them when they're causing you issues, when you see contamination. Just like with a connector. When you inspect it, if it's clean, then you don't clean the connector. Somebody had recommended, and this is actually a great recommendation, which I didn't mention in the video. So for that cleaning tool for the bulkheads, the one that I mentioned that has that little floss, and so you can actually apply some of the cleaning solution to the end of that tip and then put it into the bulkhead. And so that allows you to do a wet-dry method for the bulkhead side as well. So that's really a good tip for cleaning bulkheads. Now, another one is they get quite a few SFP failures. We do have, so SFPs are interesting. We actually wrote a really good app note on SFPs. So I would really encourage you to go to expo.com, and then under our support site or somewhere within the expo.com site is an application note on inspecting SFPs. So keep in mind an SFP, and there's different types of lenses for SFPs. So the transmitter side, you can normally inspect. The receiver side, not so much, because the receiver side, if you think about it, is a detector. And so if you're getting a lot of failures from SFPs and you think it's contamination, you are able to inspect one side but not the other. So there are some issues or some complexities around SFPs. It's probably more of an answer than I can actually cover here. But I encourage you just to go to the expo.com site. We have a really good application note on SFPs and how to clean them and inspect them. As far as somebody mentioned the cost of the 430B probe, I'm an engineer, and so I don't really know what the cost is. If you're interested in a quote, I mean, obviously, once you fill out the survey, you can put, a request to have somebody contact you. And then, of course, it depends on what company you work for and what part of the world you're in. But if you email isales@expo.com, they'll be able to answer you. But if you fill it out in the survey that you would like somebody to contact you, they can get you that information. So somebody asked you, when you clean wet to dry, I'm guessing you may get scratches as well as cleaning dry only. Absolutely. I mean, you're dealing with optical, you're dealing with glass, and so if there's any sort of particle or material that's on the cloth, so if you're working out in the elements and you get some silica on there, I mean, obviously it is possible to scratch it. We're dealing with very small sizes here, and so that's one reason why they say lightly. But honestly, in all the years that I've cleaned jumpers, I mean, it can happen. But if you keep a nice, clean work environment as much as possible, then you can minimize that. Great question. The probe can view MPO connectors, and so we're seeing. Traditionally, we saw a lot of MPOs inside of data centers. We're starting to see the need for denser and denser applications for connectors in the field. So we do have a specific MPO probe tip. So this, obviously we can't cover everything in a 15-minute video, but we have a lot of different styles of tips for a lot of different applications, and one of them is MPO. So if you do have, say, a 12 fiber or a 24 fiber MPO, We can handle multi-rows. And then, with the large field of view on this probe, we're able to really take a, to look at it. And we also have a special application for MPOs that has a picture-in-picture, which is really cool. So you can zoom in on the connector, and then with the picture-in-picture, you can see the adjacent connector. So it works really, really good. Now, somebody asked about the cleaning solution that I used. So it's the Electro Wash from Chemtronics. I've actually had that particular Chemtronics kit for, I think, about 9 years. 9 years ago, I meant to order one bag, and I ordered one case. And so because I don't work for a living anymore, I do a lot of training, I don't clean as many connectors in the field. So I've actually been working on this case of Chemtronics. So that's why I have the older style cube. There are slimmer ones now, but that cleaning material is really good. It's called Electro Wash, and I encourage you to use fiber cleaning solutions. They last a long time. They're very affordable. They're much more effective than 99% alcohol because it's engineered chemically for fiber cleaning. And when 80% of network failures is cleaning connectors, it really is important that you have the right tools for it, whether it's an inspection probe, whether it's some sort of test set like IOLM or OTDRs to identify bad connectors, or the right cleaning material. It really is fundamentally important to keep those connectors clean. And that's one reason why I did this video for one of my customers is they're spending a large amount of time rolling technicians out to clean connectors. So when I was a technician maintaining remote sites, it was not uncommon for me to drive 60 miles up to the top of the mountain to wipe contamination off the end of the connector because I was taking bit errors. And so we hope you enjoy this presentation. Please fill out the survey. Again, I didn't intend for this to be part of a webcast, and I hope you enjoyed it. I'll be doing some additional content, some specific to webcasts. We have one coming up in August that will send announcements out, and hopefully you found this useful. And if you have any additional, again, just fill out